Okay, welcome back to part 6. So in this one, we're going to learn a little bit about rendering in Unreal Engine. So I've got our project open here, and we're going to render a 360 turntable of our product viz shot. Right, so I've got a sequence that I've set up. We've got a camera and a target point that are spawned in, and we've got our product mesh here. So on the product, we've got a couple of animation tracks, really just the rotation on the yaw or the Z axis of this. So we're starting at a 180 degree angle here, and then over 72 frames, we do a 360 rotation so that we end here on frame 72 at a value of 540. If we play through this animation, we see we get a nice 360 turntable. So rendering in Unreal Engine, there's really a couple of ways to do it now that we're in 5.4. We've got movie render queue and we've got movie render graph. Movie render queue is going to be the standard way of doing this right now. Movie render graph is a new feature in 5.4. It's not really complete, it's really experimental still. There's a few things that don't work in that system so far. Like we can't render material IDs. There's a few things that aren't supported there. So we're going to stick with movie render queue for now. And so movie render queue, we're going to access through the plugins menu. So we open up our plugins, we're going to search for movie render. And we should see these two first ones here, movie render queue and movie render queue additional render passes. So we'll turn both of these on and click restart now. We'll have our project back open. And we'll go back into our level for our product viz shot and go into our sequence and open our sequence. So let's jump back into our camera, just verify everything's still working. It looks good. So rendering this out, we can render out a couple different types of outputs from Unreal here. And the way we get to the rendering menu is going to be with this clacker icon here in the sequencer. So we're going to open this. This is going to open up movie render queue. And you can see by hitting that button, it's going to add a job for the sequence that we have open. So you can see sequence product viz shot is here in the job list. It's got a settings column and an output column, as well as a status column. And the cool thing about movie render queue jobs here is when you have one selected, you can see off to the right, you can see the job name, what sequence it's pointing to, and what level it's pointing to. So it's possible to queue up a bunch of different jobs using this tool that will render scenes that are in different levels that are pointing to different sequences. So for example, if I have this 360, say I've also got, a collection of still shots or some other animation for this that live in different sequences, I can queue up all those jobs at once and let those render one after another without having to babysit my renders for such a long time. So to change the render settings on one of these, we're going to go into this settings column here and we're going to click on unsaved config. This is going to open the render settings window for this job. And you can see on the top left, we've got a plus setting button, which will allow us to set a bunch of different settings types in here. But we can look at the defaults really quick. So by default, it's going to give us a JPEG sequence, which has no options when you select this. It's going to do deferred rendering, or in other words, it's going to use Lumen. It's not going to path trace. And then under the output here, this is where we're going to tell it to point to a certain folder to render to, how to name those renders, the file format name, what resolution to render at, and a few other things in here. So we're rendering a turntable of 360, and for me, I'd like to use EXR because I want to have multi-channel support. There's a few things in there that we need EXR for. So I'm going to go ahead and delete the JPEG sequence by selecting it and hitting delete. And we're going to go up to plus setting, and we're going to choose EXR sequence. So the defaults on this I find work great. So PIZ compression and multi-layer turned on. And we're also going to add another setting in here for object IDs. So object IDs are going to create cryptomats for us for our product or any object in our scene. And there's a few different ID types that you can choose from. The default is going to be full, which if you hover over these, it'll say as much information as the renderer can provide, unique per material per primitive in the world. And what this means is every object or element of an object is going to have a different color ID. And where this really comes into play is if you have multiple objects that have the same material in your project, those objects will all be different colors. We can also choose material, where when different objects have the same material, that individual material across the scene will be the same color no matter what object it's on. And this is actually the one that I prefer to use most often. It's the most compatible with asset types in Unreal. For example, if you have a blueprint actor that has multiple components and meshes, the full type is not going to recognize those objects inside of the blueprint. So in that case, you would need to use material. So if you're working with a blueprint car or some other complex asset, you won't get any IDs if you use the full type. So we're going to set this to material, and we're going to include transparent objects. There aren't any in this scene, but if you had windows on a car or things inside of a headlight, this is how you would get some ID mats for that. So the next thing we're going to do is we're going to add an anti-aliasing settings. And on this is where we're basically going to control the quality of our render. So spatial samples and temporal samples. These are two different types of anti-aliasing in Unreal. Spatial is going to be per individual frame, and temporal is going to be across multiple frames. Right, so spatial samples, if you read the tooltips on this, it says how many frames should we accumulate together before contributing to one overall sample. This lets you increase the anti-aliasing quality of a sample, or have high quality anti-aliasing if you don't want any motion blur due to accumulation over time in sample count. So long story short, this is basically render the same frame multiple times and merge the results to be as smooth as possible. Temporal samples do a little bit of a different thing. It says the number of frames we should combine together to produce each output frame. This blends the results of this many sub-steps together to produce one output frame. Essentially what this does is it takes multiple frames one after another and finds what's common between them and blends them in a way so that they appear nice and smooth. So really the best thing to do is use a combination of these. And I like to use a higher spatial sample count than temporal sample count. And really the only thing that matters here is that these need to be a multiple of 8 when you multiply these together. So you want to work in multiples of 8 here. So we'll say for spatial sample count, we'll do 32. And for temporal sample count, we'll do 4. All right, and you'll get this warning here that says if the product of temporal and spatial counts equals 128 is greater than the number of TAA samples. Basically, this is a warning that tells you need to turn on this checkbox. It says override anti-aliasing. So we turn this on and leave anti-aliasing method set to none. This basically means let the multiple of this be what drives how much anti-aliasing is being contributed in the render, right? So we'll leave that alone and take a look at what else is in here. So you've got use camera cut for warm-up and render warm-up frames. So really these only matter if you've got effects that are happening in your scene, like you've got a particle emitter or some other kind of simulation going on. You need the engine to warm up and get those features rolling before you start capturing frames. Since we're just animating a 360 on a static object, that really doesn't matter. So we'll leave these turned off and leave them at their default. So next thing I want to do is go into the output folder here. And for our output directory, by default, this is going to go into our project directory on our hard drive, right? So we've got our project that we created in the location that we created it in, which in this case is Intro to Unreal Part 6. So within that project folder, there's going to be a saved folder and then a movie renders folder. And these are going to go into that folder. So the file name format, we can say we've got sequence name dot frame number, and that will be the individual file name for our EXRs that get output here. One little tip on this section, if you delete what's in here, you'll get a drop down of all the different flags that you can put in for a file name format. So if you want to, you can timestamp these, you can put the frame rate into this, all kinds of different things that are nice sometimes to have as an identifier on your renders. So we're just going to keep this at the default. So sequence name dot frame number. We're going to leave the output resolution at 1080p for this. And we're not going to override the frame rate to anything here because we have frame rate set in our sequencer here. This one is currently set up to be 24 frames per second, which is great for rendering videos like this. We can tell it to be a different frame rate, and we can tell it to use a different playback range than what is set up in our sequencer. So right now we've got this going from frame 0 to 72. If we want to render just a slice of this, we can tell it to do that through here. So use custom playback range. We can say render only frame 32 to 48, for example. So it'll only render these frames and ignore the rest of them. So this is good if you want to split up your render across multiple machines. If you're doing a very long path tracer render, you might need to distribute those renders to multiple machines. But since we're just doing a Lumen render for this should be very fast. So we'll leave these at the default. Okay, so we'll save that. That looks good. If we take a peek at the other settings that are available in here, there's a few things that we can do. One of the things that's very useful is a console variable input here. So if you need custom console variables active for rendering nanite meshes in Path Tracer, or changing the type of denoising that's happening in Path Tracer, which we'll take a look at later, we can enable those console variables at render time through this settings menu right here. We can also render some very basic render passes. So these are the ones that are available through the view modes in the viewport here under the lit menu. So we can render directly, the detail lighting, the lighting only, the reflections, the unlit. So there's a few things that we can do here. These are not true render passes, so don't be confused by this. To render actual render passes with Path Tracer, there's a bit of a different setup that we'll cover later. We can also do panoramic rendering, which is going to render a 360 camera from here, but this only works with Lumen. This does not work with Path Tracer. If we did want to render a Path Trace render, we can choose it from here, and I'll add one just temporarily here. So this deferred render and Path Tracer, this is really a one or the other type of situation. If you want to render a Path Tracer render, you need to disable deferred rendering. You can render both of them at the same time, but the anti-aliasing settings between these two are typically a little bit different. So you want to set this up for either one or the other. Okay, so we're going to delete the Path Tracer, come back to plus settings. The other thing that is nice to add sometimes is this game overrides settings, and really the defaults for these are fine. What this basically does is just crank the engine all the way up to max, make sure that everything is running as high quality as possible. Things are not being culled by distance. There's a lot of things in here that happen. And you can take a look and hover over the tooltips for each of these just to see what all of these do. Okay, so I think we're good with this. This will be a good first render settings. And if you wanted to render something else later and you don't want to have to reconfigure all of these settings, you can actually save this as a preset. So up at the top right here, unsave config, we can open this drop down and say save as preset. And so when I'm saving presets in Unreal, I like to create a folder for them. So we'll do create a new folder, and we'll call this MRQ for movie render queue. Go into this. We're going to call this MRQ Lumen 1080p. And maybe we'll throw 24 FPS on there. So we have a good idea of what render setting this is. I know that this is a Lumen render. It's at 1080p. It's going to render at 24 frames per second. I have a pretty good idea of what that settings file contains. Okay, so now we know that we're using that preset. We'll hit accept. And now in our render queue here, we can see we're going to render this job with this settings preset, and it's going to go to this folder. So we'll go ahead and hit render local, and we'll get our render started. Usually the first time that you kick off a render with movie render queue, it's likely that it's going to compile shaders specifically for the settings that you have set up in that settings template that you made. For example, if you are rendering Path Tracer at this time, it's going to need to compile shaders for path tracing. But this is typically a one-time thing. If I went back and re-rendered this a second time, it shouldn't need to compile these again. Okay, so shaders are compiled. We can start our render, and we can kind of see what's happening here. So on the bottom left here, current sequence, it's our sequence name, total frames that we're rendering, how much time has passed, and how much time it thinks is going to be remaining for the rest of our frames here. So then we got our current camera cut, which says cut name no shot, and that's because of the way we have our sequence set up here. Our camera cut doesn't have a cut name, really. It's using the default of no shot and what camera is connected to it. It is the only shot that we're we're rendering, so the only cut that we're rendering. And then we're on frame 13 already here. And so we can see the subsamples. This is going in increments of what we set in our anti-aliasing settings. So I believe we did 32 by 4, which gives us that total of 128 samples. So we can just let this cook for a little bit. I'm going to pause here and let this render finish, and we can take a look at what we got out of it. All right, so our render is done. That preview window goes away. And we can click right on this output link right here to go to the folder that they went to. So we'll go to this, and we can see all of our EXRs came into this folder inside of our project folder. So our Intro to Unreal P6 folder is here. So inside Saved, Movie Renders, we've got all of our renders here in EXR format. And we can take a look at what these look like in another program like Nuke. So we'll open up Nuke here and see what we get. All right, so we've got Nuke open, and we want to drag those renders in here. So I'll take that whole folder and just drag that in and see what our renders look like. So if we hit L to play our render, Nuke is going to cache these first. So we'll get this cache, and we should get a little bit more of a real-time playback. Okay, so here's our renders. They look nice and clean. I can see a few things in here that are maybe a little problematic. There's a touch of motion blur going on our render here, and we can take a look at how to control that in a moment. But I wanted to just really quickly come and look at the render passes that came in by default here. So if we look in our channels for this render, we can see we've got, just an RGBA, and we got some of the Cryptomat elements in here as well. So if we add a Cryptomat node and plug this in, we can see what our Cryptomats look like for this. So this came in with really just two materials that it could see in our camera, right? So we've got the material that's on the background, and this object here for the controller is really just one material. Okay, so it did exactly what we wanted it to do. It's separated by material, and we can see those separated here. So if we want to, we can select our controller here and see what our mat looks like for this. We can play through this, kind of see if we notice any motion blur going on. Looks pretty clean to me, so I think we're good. Okay. So now we can use this to control different aspects of our render with compositing. This isn't really a compositing video, but just to give you an idea here, we can control different elements of this using those Cryptomats, which is really nice. So we can do some basic compositing with our renders out of Unreal just with this basic setup here. So everything looks good. Our EXRs came out well. I want to talk a little bit about controlling some of that stuff like motion blur here in Unreal. So motion blur in Unreal is a bit of an interesting topic. It's a little bit odd. This is controlled through the post-process volume in our level here. So if we go to our post-process volume here and we scroll down to rendering features, we've got the motion blur section in here, which by default, the settings in here are a little bit strange, right? So the amount is really just a strength of the motion blur, whether it's 0 or 1. Default is 0.5. We can set this to 0 and override our shot to have no motion blur whatsoever, but I'm going to start a render on this and kind of show you what happens when we do this. I'm only going to let it render a couple of frames, and we'll see really quickly what I want to get to here in a moment. So let this render a few frames, and then we're just going to hit escape to cancel this render. And we're going to get this message log full of warnings here. So if we get these where it says too many temporal samples for the given shutter angle tick rate combination, set cached frame timing called in 0 delta time. This looks like a bunch of scary errors that you get. Basically what this is complaining about is, the shutter timing in your camera is a little bit off compared to what Unreal is expecting it to be. To be honest, these errors can be completely ignored. So those renders that come out, they're going to look just fine. And we can set this to be, a value of what it's expecting. So it says falling back to 1/24. So we can actually try doing that. So 1 divided by 24, it's going to give us a value of 0.041. we can clear these errors, close this message log, and try rendering this again and see what happens. So we're going to let a couple of frames render here, and then we're going to cancel out of this. And this time we didn't get any warnings, right? So it's almost no motion blur because we have 0.04 for the motion blur value. So there isn't really going to be any visible motion blur in our renders, but it's also going to prevent Unreal from complaining to you about this. So just one little hack: if you don't like those warnings coming up, you can just put that value there and it's going to stop complaining. But just know that if you do have this set to 0 and you get those warnings, they really don't matter. They're not going to impact your render whatsoever. That's a basic render in Unreal. So what if we want to path trace this instead? So we're going to open up our settings here. So we're gonna alter some things within this settings file, and we want to save this as a different render settings file. So right away, I'm just going to go ahead and save this as a different preset. So we'll do save as preset. And this time we're going to change this from Lumen to path trace for the preset name. Save this. And this time we're going to take our deferred rendering, we're going to delete that. And then we're going to go up to plus setting and say path tracer. So the path tracer works a little bit differently. You know, if you're used to looking at path tracing settings in the post-process volume down at the bottom here, so we've got path tracing, we've got max bounces, samples per pixel, max path exposure, all of this stuff in here. This samples per pixel, which is the overall quality of our render, this doesn't exist as a setting in the path tracer here, which is a little bit odd. The way we control this is through the anti-aliasing setting here. So the product of these two numbers here, that is going to be our samples per pixel. So whatever this multiplies together to become, that's how many times it's going to sample our image to produce that final result. So right now we've got 128 samples, right? So it's not really a whole lot of samples, but we can see what we get from this. All right, so we've got the denoiser turned on. That is controlled through the post-process volume. If you don't want to denoise your renders, which I don't in this case, I want to show you what this looks like. We'll leave that turned off, and then we'll save our preset just to save those changes, accept, and we're going to render this again and see what we get. So those renders are going pretty fast, right? They're only a couple of seconds per frame. And keep in mind, this is a fairly low resolution render, 1080p. It's only 128 samples. And this is a fairly fast computer. So frames are going to come out pretty quickly here. So I'll let this render about 20 frames and then we'll take a look at those in Nuke. All right, so we got 20 frames done here. Cancel our render. We're going to get those warnings again, which is fine. We'll ignore those. So we'll pop back over to Nuke and we're going to reload our read here. So if we zoom in on this, we should see a little bit of noise in our render because we have the denoiser turned off. And if we play through the first 20 frames on this, we can see if there's any noise swimming in our render. So this looks pretty uniform to me. I think this looks pretty decent. And this is a basic path tracing render here. So I'm going to go back to Unreal, and this time we're going to turn that denoiser on. And to make this even more exaggerated, we're going to set our anti-aliasing even lower here, so even lower quality. So 32 by 2 is only 64 samples. We'll accept, and then we're going to render local again. So these renders should be very fast at this point, really only about a second and a half per frame. And we should see a bit more noise this time in the initial render, but these ones are being denoised after render time. So we'll do the same thing here. We'll let about 20 frames render, and then we'll see how that denoising result looks in Nuke. Okay. We've got that done. Pop back over to Nuke, and we'll reload that render one more time. So our render looks really clean. It's really smooth. No noise in the render because our denoiser just blasted away any noise that it found. And we're going to go ahead and play this from the beginning. So the one thing that you need to be cautious about with denoising in Unreal, and it's going to be a little bit subtle because this is such a simple scene, but the standard denoiser in Unreal causes a lot of swimming in the render. It's particularly noticeable in areas where there's something like a carpet fiber or maybe a grass, that type of thing, where there's a lot of fine detail that can get blown away by a denoiser. That's really the give and take with the denoiser, is that fine detail tends to get lost. The denoiser can't really discern fine detail from noise all the time, right? So I can see just a little bit of noise swimming going on, like denoising swimming going on in the render here. It is really quite subtle, but it is more obvious in more complex renders, with more fine detail going on. So to get that solved, there's a couple of things that we can do in Unreal. So remember I mentioned in our render settings, there is the console variables here. If we add the console variable setting, we can say, do we want to add console variables here? So we can say plus for add element, and then we can add a console variable or cvar, and we can give it a value. And every time we render now, it's going to put these console variables into play and make sure that those are in effect while it's rendering. They don't have to be present in your project while you're working in the viewport. And you can use this to really crank up certain settings like render quality or some other things about your project here without having to bog down your viewport. So it's really handy for rendering a little bit more intensively than you are working in real time. Okay, so for the meantime, we're going to hit accept on this, and we're going to pop over to our plugins again. And this time we're going to look for the Optix denoiser. So Optix denoise is still set to experimental in Unreal, but I've been using this in production for quite a while now. And this is an alternative to the standard denoiser in Unreal Engine. So we're going to restart the engine, make sure we save what we have. Let Unreal kick back up. And we're going to open up our level and sequence again. Okay, so we'll go back to our movie render queue, go to our settings, and we're going to load that preset. So MRQ path trace. Yes, import these settings. And then under settings here, we're going to add that console variables thing again. We're going to add a console variable. And for this, we want to start typing in a console variable to tell Unreal to use the Optix denoiser. So in our console variable here, we can start typing in our console variable that will tell Unreal to use the Optix denoiser. So we're going to do r.pathTracing dot spatial denoiser dot type. This is the one that we want, so now we can select it from the list here. And we're going to set this to a value of 1. So this tells Unreal to use the Optix denoiser rather than the default one. The default one here is going to be set to 0, so we want 1 to tell it to use Optix. Okay. So Optix does a really good job of handling denoising swimming from frame to frame. And you won't get this random pattern that's happening all over the place. It really ends up looking like some really turbulent noise in your render. So we'll save this. We're going to come over to anti-aliasing, and we're going to crank up the settings on this a little bit. So we're going to set spatial to 64 and temporal to 8. We'll save our preset, hit accept, and then we're going to render local again. So our render should spin up. These frames are going to take a little bit longer now that we have 512 samples rather than 64 or 128. You can see we're still only at 2-3 seconds per frame here. It's really not going to take much time at all. So we'll let this cook for a little bit. We'll pause the recording here and then we'll come back. All right, so our render is just about done here. Let's let this last frame finish up, and then we'll update over in Nuke and take a look at what we got. Okay, so over in Nuke, reload one more time. And this time, take a look at our render. let that cache. So now we can see the denoising that happened in our render is no longer kind of swimming in the areas that it was affecting before. So the turbulence that was there from non-temporal denoising is gone now. Now it's treating this a little bit more temporally. We get a much cleaner render here. So this is a great option for doing denoising on longer animated renders that you have lots of motion in, lots of high detail. This will really help preserve those details. So we'll back out of our slice here. Just gonna take a look at the rest really quick. And you can see everything is looking nice and clean now. Perfect. So back in Unreal, one last thing before we end this one. We mentioned before that we can render passes with path tracer here. So within our post-process volume, like we saw in the lighting video, if we go under the path tracing section here, we've got lighting components. So if we want to render these lighting components, there is a bit of a complicated setup to get them to come out in one movie render queue setting. The easiest option really is to just uncheck what you don't want and leave what you want enabled. So for example, if I just want the specular and indirect specular here, I can uncheck everything else. Go to our render and render this again. So we should see just the specular happening in our render now. So we can see just that effect here. So we'll cancel this. And maybe for the next one, we want to see just the diffuse and direct in diffuse. So we'll render this. And this is only the diffuse light. So really we could combine this render and the previous one. So direct lighting, indirect lighting, and our specular, indirect specular. And that really would be a back to beauty for this render. This is a very simple scene. There's not a whole lot going on. But just keep in mind that you do need to set up different outputs for these. These are going to be different EXR files. If you want to render just this direct lighting, we really need to change our settings preset in here to point to a folder for direct lighting. And maybe even include in our file name here, we could do something like underscore direct lighting. And that will give us a render that is named correctly. We can come back and repeat this for specular, and we can take those and combine those in compositing after the fact. So we'll cover a bit more on doing these render passes a little bit more down the line in these videos, where we get a little bit beyond this basic level of Unreal knowledge here. This is really the last part of the Unreal basics that we're going to cover. Pretty much everything after this point, we're going to start diving into some more car related things. Hopefully this has been helpful for you to kind of get your feet wet in Unreal, kind of get used to what the interface looks like, how the different systems work together, how to light, animate, render. Starting with the next video, we're going to pull in a freely available car from the Wire Wheels Club online, and we're going to go through some Maya prep on that vehicle. Right, we're going to get this ready to bring over into Unreal. We'll see some best practices to use there, how to set things up, get things working really efficiently, and then we'll start prepping that in Unreal and set up some lighting scenes for that. All right, so hopefully this was helpful. If you have any questions, please let me know. Otherwise, I'll catch you in the next one. Take care. If you learned anything from this free video on YouTube here, please leave me a like and consider subscribing to the channel, and look forward for the next videos.